Hello students, today I am going to discuss about multiplexer, decoder, demultiplexer, encoder. So these devices belongs to combinational circuit. Now first of all, if we discuss multiplexer, this is a basic block diagram of a 4:1 multiplexer. Now if what is the definition of multiplexer? The definition is a multiplexer have a n number of selection line, 2 to the power n number of input line and 1 output line. So n number of selection line means this is the selection line. If we have n number of, that is here it is 2, so capital N is 2, and 2 to the power n number of input lines, so 2 to the power 2, so that means it is 4. So 4 input lines, and we have a 1 output line. So this is basically on the architecture of a multiplexer. Now what is the job of the multiplexer? This selector line will select a particular input, and that particular input will available or appear at the output, or we can say that the information on this particular input, on any particular input, can be passed to the output depending on the selection line. Suppose we have a information 0 available at I2. Now if we select this I2 input by this selection, then y will be equal to 0. That means the value of I2, or more in general we can write down y is equal to I2. Now this is a typical 4:1 mux. The minimum will be 2:1 mux. The minimum unit of a multiplexer, there will be 2 input line, 1 selector line and 1 output line. So this first input will be 0 and the second input will be 1, I1. Okay, and this is the selection line S, and this is the output. So this is basically 2 cross 1 mux. So this is a minimum block of a multiplexer. Now if we set S equal to 0, y is equal to I0. If we set S equal to 1, y is equal to I1. Now below we described the characteristics table of multiplexer, 4:1 multiplexer. Now one thing, we have another input which is called enable. Enable means enable bar. So if we apply 0, then this pin will activate and the IC, that means 4 cross 1 mux, will activate. If we apply high to this pin, enable pin, it will deactivate this IC, deactivate this 4 cross 1 mux. So that is the job of the enable. So if we look into this characteristics table, truth table, obviously the enable should be 0 to activate this mux. Then when S1 and S0 both are 0, then the output will be equal to I0. That means whatever information available at I0, that will appear at the output. Similarly, if we select 0, 1, the y is equal to I1. Similarly, if we select 1, 0, y is equal to I2, and similarly for 1, 1, y is equal to I3. And if we apply 1, then nothing will work. So all the IC will be deactivated. 4 cross 1 mux will be deactivated. So depending, this is the characteristics truth table of this 4 cross 1 mux, and we can write down the equation. This is SOP representation of y. So obviously from this operation we can say that y is equal to I0 into S1 bar S0 bar. Okay, S1 complement S0 complement. So from the similarly we can write down that I1 y equal to I1 when S1 complement S0 1. So this S1 complement means it's bar and S0 1. And above all, these things will be ended with a enable input. So if the enable is 0, then y is there. If enable is 1, the y is equal to 0. So this is the basic what can I say, output equation or SOP representation of the y. Now depending on this equation, we can implement a 4:1 marks using a 4 input AND gate and a 4 input OR gate and using some NOT gate. So this is nothing but a basic logic implementation of this equation. Obviously, so depending on this equation, so this is the logic realization of 4x1 marks with active low enable. Active low enable means we are talking about this enable pin. Okay, in some cases the enable will activate at 1, means at high. In that case, the bar sign, this complement sign will not be there. So this is a 4x1 marks, and for an example, commercially 74153 is an example of a dual 4:1 marks. That means in a single IC there will be two 4x1 marks. 74151 is basically 8x1 marks. 74150 is equal to 16x1 marks. So these are commercially available ICs for multiplexers. So we can, since we can always design a higher order marks using the lower order marks. So you can expect some question also, the design 8x1 marks using 4x1 marks, and also or in design a 16x1 marks using 4x1 marks or 8x1 marks. So this kind of design related problem we have to practice, and also we can implement different combinational circuits, different arithmetic circuits like adder, subtractor using marks. We can design any kind of combinational circuit using marks as well as decoder also. Okay, so that part is also there. So now I will discuss about how to design a higher order marks using lower order marks. Okay, I will directly go to that part, then I will discuss decoder portion. Okay, this is cascading of the decoder, multiplexer implementation. This is one. This is the one problem. Okay, so this is a typical 8x1 truth table of a 8x1 multiplexer. We have, for 8x1 we have 3 selector line, 8 input line and 1 output line. So same as 4x1 marks, we derived this equation from this typical truth table of 8x1 marks. Now how to implement this is implementation of a 8x1 marks using 4x1. See, we need, obviously this is very obvious, we need two 4x1. This is one 4x1, okay, and this is another 4x1 marks. Okay, that these two output will be ORed as the output. The final output is Y. Okay, so this is another implementation. This is one implementation where we need two 4x1 marks. In the second design, we can design a 8x1 marks using two 4x1 marks and one 2x1 marks. So this is another design. So how can I do that? If we look into that factor, that for a 4x1 for 8x1 marks, if you see that up to this level, this S2 is 0, okay, and after that this S2 is 1. So this concept, this basically actually helps us to design of a 8x1 marks. How? So obviously, if we connect this A, that means the MSB of the selector line with the enable line, of the marks of the two marks, 4x1 marks. That means when this is basically our S2, this A. So when this A is 0, this marks will be activated, and since this A is connected through a NOT gate to the second marks, so this marks will be deactivated. A means my S2. So obviously if we see that, then when S2 is 0, so when S2 is 0, the upper one marks is activated and this one will be deactivated. So obviously the Y0 will be equal to D0, D1, D2, D3 depending on the S1 and S0. Okay, and in all the cases Y1 will be 0. Very obvious, because this 4x1 is deactivated. Now for the second half of this truth table, when S2 becomes 1, that means A becomes 1, then the upper one marks will be deactivated and the lower one marks will be activated. So in that case, Y1 is equal to D4, D5, D6, D7 depending on the value of S1 and S0. So overall, this Y represents the function of a 8x1 marks. The same thing are happening in the second design. Only we integrated the output Y0 and Y1 through a 2x1 marks. So there are different design available. We can design a 16x1 marks. So try this. If you cannot design, then I'll explain how to design a higher order 16x1 marks using 4x1 marks. So next class we will discuss about different logic function implementation. So this is the class where we discussed only the introduction of multiplexer and how to design basic building block, how to design the higher order marks using lower order marks. Thank you for listening this video lecture.